Hi everybody, welcome back. I'm still here at the computer desk because the basement is a complete disaster. They did the drywall sanding and everything before they started doing the finish trim and all that. And the whole basement is just coated with this layer of dust. I mean, it's terrible. They have things piled, tools and construction. I can't even get down there. So we're going to do the first. This is part one. I don't know how many parts I'm going to end up doing of the question and answers, but this will be the first part, and I'm going to try to do questions that don't require me to be down on the bench for obvious reasons. Now, what I did was I printed out what we have so far, and as you can see, it goes on and on. There's lots and lots of pages of questions, so obviously I'm not going to get to everybody's question. A lot of the ones that are on here, sometimes they're related to one another. So you asked a question that's very similar to one that somebody else answered. I'll try to kind of clump those together. I also color-coded the questions based on what the subject is, and I broke it into 4 sections. Personal questions about me or something like that. Questions about equipment, like test equipment or audio gear, things like that. Components, which I've gotten a lot of transistor and capacitor questions, obviously. And last but not least, I have to look it up myself, how-to. That's what I call it. So the things in blue are how-tos, like how do you do this, how do you do that, you know, how do you look something up, or how do you calibrate this particular thing. All right, so enough about that. Let's get started. And I'm not doing this in any particular order of which I received the questions, but just trying to find ones that are suitable to where I'm sitting here at my desk right now. So let's take a look here. We'll start out with a funny one. One important question: how many times do you visit the bathroom a day? You said every question is aviable. So he's just messing around with me, and he says that he is. But yes, it depends on how much coffee I drink, of course. And the older I get, the more I go. I've got my cup of tea right now because I've already had 2 cups of coffee. And this is a hibiscus cinnamon tea. Picked it up while we were on vacation earlier, and it's pretty good. All right. So some of the transistor and capacitor ones, I'm not going to be able to answer without showing you some things on the bench. So I'm going to kind of skip those out. Here's a good how-to one, and I'm going to have to refer to some of you for it. I'm building out my ham shack this year, and I have issues with planning both the RF and electrical safety grounding. The specific issue I have is running a ground wire to a gable end on the 2nd floor. I have a metal roof and gutters that are in the path, and the ground wire is likely at a 1/4 or half wavelength for some of the bands. The idea was to have a single point ground for radio equipment, mast and lightning arresters at the gable end. But I'm interested in the topic in general. It's not something a lot of people really know much about. Well, that last sentence is it. Grounding is very complex. Grounding is every bit as complicated as antenna design itself. As a matter of fact, let me adjust this a little bit. Looking at, like, for the little bit of time I worked for GE in their X-ray industry. GE teaches an entire, well, I don't know what they do anymore now, it's been so many years, but back in the day, they actually would teach an entire 1-week class on power and grounding. That's how important grounding was. Some of the Siemens X-ray equipment that we worked with, they actually used isolated grounds to have a true star grounding system, to the point where the rails of the, the overhead tube crane where the X-ray tube was, it actually was totally isolated from any of the building structure or anything, and had one common point of ground that went to a star grounding system in the main power cabinet. So grounding is no joke. And there's different things to think about when you're thinking about grounding, especially when you're talking about high frequency things. Now that X-ray machine I was talking about, it ran at high frequencies. It was not running at line mains frequency. RF, obviously, if you're building a ham Radio Shack, you definitely are going to be operating with high frequencies, right? And so that type of grounding versus actual power grounding for safety are two different subjects in and of themselves. And I think you've alluded to that by saying have issues with planning both the RF and electrical safety grounding. So you already understand the concept of what this is about. When you're using RF grounding, and again, I am nowhere near an expert. A lot of the Elmers out there, and you know who you are, will have a much better understanding of, when it comes to RF, of how to design your grounding. In my own personal shack here, I don't use it a lot. I don't go on air hardly at all anymore. I just don't have time. But I actually have a 3-inch wide flat copper strap for grounding. There's also braided strapping you can use for grounding. You don't want to use normal, round pieces of wire. You want, the RF grounding, you hear about the skin effect, and you want your grounding to be sufficient to give you a very low DC resistance, but you also want it to be have a low impedance. And in order to do that, you need to use the proper copper strap, and you need to run it in such a way that it is common to one area. So mine comes in, I have two long copper rods driven into the ground. And I actually drove them into the ground close to the house. And the concrete of my driveway and everything goes right up to the foundation of my house. I actually had to take a hammer drill and cut holes down through there. And I drove those rods about 8 feet into the ground, two of them. I spaced them about 6 or 8 feet apart. And that goes to a bus bar, a grounding bus bar, the solid copper, right when it comes into the house. And then I have that copper strap coming in through a lead through in my house, through the foundation, to that copper strap, or to that bus bar. And then I have, coming from my antenna, now I have a 43-foot vertical antenna out in my yard with ground radials. The ground radials are not tied into the ground as per se. They're actually insulated wire, and they run out. There's probably about 38 of them, I think there were. And they go out in all directions in my yard all around, and they're random lengths and so forth. And that's all tied to one common area that ties in again with the ground. And again, mine might not be perfect, but it does seem to, as far as being resonant at different frequencies and everything, it seems to work pretty good. Then of course the radio and everything ties in, on that bus bar again. Also, I have a lightning arrestor. It's outside. It's in line with the coax. I have an unbalanced system because it runs on coax and so forth. So all these things you have to kind of plan out based on the type of antenna. Like if you're using, a vertical antenna, or like a Yagi antenna with multiple elements, or even if you're using one of the long wire antennas, like a dipole type thing, or sloped, they're all going to have kind of different ways that you're going to want to ground them. So that's some things you might want to pick up. The ARRL manual, it has they have really good sections on that in it. When it comes to safety grounding, that is another whole thing. That's more about electrical grounding for your power, for your incoming mains and so forth, and that you're going to kind of follow the rules of your country and how your mains and everything works. And you do want to have those grounds bonded together at some point in time. Probably, like in my case, I have it on the grounded bus bar. when you start dealing with structural things in your house, you're talking about gutters, metal roofs, wiring that's running through your walls, and you're going to have the antenna in close proximity to that. Just understand that all of those things are going to affect the propagation of that antenna, and more so than the ground will. So plan that out carefully. Now, everybody has a different situation. I don't really have any HOA laws or anything at the house where I live, so I got this big antenna sticking up out of my yard, and my neighbors teased me about it and said, thanks for putting a lightning rod up in your yard. It'll hit you instead of us. So we joke about it. But truth be told, you need lightning protection and everything. That's another thing. You make sure you have lightning arresters in line with your coax. Make sure you have proper ground that will dissipate that lightning as much as possible in the outside of the house before it comes into your shack. All those things are very important. Disconnect your antenna and so forth when you're not using the radio. You don't want all that stuff connected to your gear. In the case of a storm or something, it can damage your radio, beyond just, worrying about a fire or something in your house. It's no joke. So again, go to the ARRL manual, look up, read the material they have on grounding. You'll see there's a lot there. Hope that answers some of it. Okay, here's one on capacitors. Tony, what are your best sources for capacitors now that many of them have reached end of life? All right, I'm going to make a comment on this. Might be a little bit controversial, but it's what I personally believe. Yes, a lot of the capacitors that you're used to seeing on comments and on YouTube videos and on forums, Audio Karma, DIY Audio, yes, they are becoming extinct. A lot of those don't really have a big market in the world other than folks like us who like audio. So they just quit making them. But really, they're not quitting making them. A lot of capacitors that are still in production today have very similar specs to the audio grade capacitors that we are used to using. It's just an inconvenience. Back in the day, if you bought an audio grade capacitor, that just means that it's a capacitor that has the specs that are good for using in the audio path of audio gear. That just means they work well in that frequency range, between 20 hertz and 20 kilohertz. Stuff that works at mains frequency, your main target frequency for that is, 50, 100, 60, and 120 hertz, because those are kind of the four frequencies you're going to deal with mains rectified AC. So bottom line, there are many, many capacitors out there still that have low ESR, low leakage. Those are the two of the big ones you want to look at. You want low ESR. ESR is equivalent series resistance, and there's several different things that cause that. And I've done capacitor videos. Go back and look at them. You'll hear some of this stuff. So low ESR. ESR will affect how a voltage is going to change with time. The more ESR you have, it's just like putting a resistor in line, and you're basically creating an RC time constant, right? So in a perfect world, you would have 0 ESR, but that's not always possible. In other applications, the super low ESR isn't super important, but with audio, it is. It can make a difference because you're dealing a lot of times with high impedance circuits inside there, especially in the voltage amplification section where, you're using constant current sources and things where you only have a couple milliamps. A little bit of ESR can change the slope of something, when a voltage is changing. Second of all, low leakage, okay? Every capacitor has some amount of leakage. Electrolytic capacitors or chemical-based capacitors have higher leakage just by nature, by their design, than does a film capacitor or a ceramic capacitor, for instance. Even those will have some leakage, but not to the degree of electrolytic. So when we're talking about low leakage caps, we're really talking about a type of electrolytic cap. Some types of capacitors, electrolytics, do have a considerable amount of leakage when you're dealing, again, with small signals. So that's a big deal. So for instance, the Nichicon, I believe it's the UKL series. I think so. Yeah, I think it's the UKLs. Those are still in production, and they're a low leakage capacitor, and they also have low ESR and fairly decent ripple current. So that's a good capacitor for audio, and I use them. Panasonic also makes a couple different versions of audio grade caps that are still around. So you can still get them. And they're still available at Mouser, DigiKey, Newark, and so forth. You can get them. Be careful buying them online at like the eBay and AliExpress type places. Although there are people who actually buy up inventories of these and sell them on these outlets, you can't always trust that they're legit. So you just have to do your homework. Look at the reviews and stuff of other people that have purchased from those dealers before you buy from them. So I believe you can still get the caps for now. That could change, but as of this video, you're still good. Okay, here's a really good one that kind of dovetails into the last question. Happy New Year from Brazil, Tony. Happy New Year to you, and to all of you, by the way, Happy New Year. I have a question. How have you been dealing with fake components? Any hints for good company sources with reliable prices that have a world shipping coverage? Thank you for your videos, your great inspiration, and so forth. That's a really good question. Now, kind of the curveball you threw me on that is international shipping. Because here in the States, Mouser, DigiKey, and Newark are the big three, I call them. And there are other ones too. There are many other small electronics companies that also sell these components here in the United States. But those are the three biggest ones. And they have national shipping. A lot of them will do international shipping, especially Mouser and DigiKey. Mouser especially has quite a few overseas warehouses and so forth. They're actually an international company. So you can get components from them. Fake components, though, you really have to go to a place that's ISO certified to know that you're going to get actual, reliable components. You buy them anywhere that's not ISO certified, they might be a reliable source, they might not be. You're just not going to know up front. Now with fake components, there are quite a few eBay stores that sell legitimate new old stock components. People that are hoarders, they go out and they buy thousands and thousands of one type of capacitor or transistor or integrated circuit or something, and they stockpile them. And then down the road, they begin to sell them off, and they make a profit off of it. And rightfully so. When the stuff becomes impossible to find, you're willing to pay a little bit more for them. Now, some of them are a total rip-off, and I just wouldn't repair the device rather than purchase a component at the prices they're asking. But sometimes, if it's a part that's normally 35 to 50 cents, US over here, and they're charging you $1 or $2, and you need 5 of them, well, it's an investment, and you spend it for the convenience. That being said, there are quite a few other dealers out there that are not so honest, especially the ones coming from China. I'm just going to say the word. China has a big problem with counterfeit parts right now. Now, there's a difference between counterfeit and fake. Some counterfeit parts will actually perform the same as the original. It's just manufactured with using a different process in a different factory, and it's being marketed as the authentic part, but it's not. You put those in a circuit, they'll work most of the time. Fake parts are something completely different, and that's what we run into the most of right now. I have a whole bag I bought of, it's like 500 2N2222 transistors. They're very obviously fake, but they operate just like normal transistors, and they're pretty consistent. And I would not use them in a place that specifically calls for a 2N2222, but if I just need a generic transistor, especially for when I'm doing experiments on the bench or something, they're so cheap that it's really, I don't have a problem doing it. I literally paid a couple dollars for like 200 of them or something. That's one example. However, there are some transistors, especially like the TO3, those oval-shaped, transistors. There's the 2N3055s. That was one of the most common TO3 transistor ever made. And those ones can cost, peanuts sometimes online. But what I found is if you take the cap, the top off of them and look inside and look at the die, it's very obviously not a 2N3055, nor is it even a counterfeit 2N3055. They literally took a cheap small signal transistor die and they put it inside the transistor case. And then they stenciled the numbers on there of a 2N3055. You put those in an amplifier that requires, or a circuit that requires a 2N3055, it's not going to work. It'll work for a little while, it'll overheat, and it'll fail because it's an underpowered device. It can't withstand 115 watts of heat, nor can it handle the full amount of current, whatever the 2N3055s with, like 10 amps or something, at up to 40 or 60 volts, something like that. You're not going to get it. And so those aren't going to work. If it's mission critical, if it's a valuable vintage piece of audio gear or a piece of test equipment or a project that you're building that you need it to be reliable and functional, you're going to have to spend the money and buy the good part from the good resource. And sometimes when you're in a country such as Brazil or something where you have to import a lot of things from Europe or the United States, the shipping becomes the big problem. I run into that all the time at work. A lot of the products that we service are, European, Siemens and Philips and so forth. And sometimes getting parts for those, if you're trying to get brand new or something like that, not always so easy. It's not going to be cheap. The shipping will, if they don't have them in stock in a warehouse over here and I have to bring them over from overseas, very, very expensive. I had to buy a camera assembly about 10 years ago. The camera itself was $8,000 for this one unit, and the shipping for it was an additional $300, $400, $500, and the whole thing was about the size of a grapefruit, about this big. But that's what you pay. So I understand that. But bottom line is, go to the reliable source. You may have to make the investment in the shipping to get it, but that's about the best recommendation I can give for that. Okay, here's a good one. The biggest problem I have when working on equipment is raised or completely detached circuit traces on the PC board. I'm never sure how to tackle this issue. What do you find works to fix lifted and damaged traces? Well, I have multiple fixes I use for damaged traces. If the trace going over to the pad where the component's going to go through, if just that very pad end is bent up a little bit, I'll just kind of gently fold it down. I'll push the lead up through the circuit board. I'll fold it over, kind of over the board, so that it pushes down on the pad, and then I'll solder it, but I'll put enough solder on it, and I'll take where the pad goes onto the trace, I'll take a little screwdriver or a hobby knife or something, and I'll scrape off the green coating on the board, the paint, and get it down to bare copper, and I'll run that solder all the way down there onto the pad to kind of make it, strengthen it. And that's a good fix, and that usually holds up pretty well. If you have a trace that's actually broken off like that, the pad where the pad is gone, In multiple videos, I've shown that problem where I've actually taken a piece of copper foil. If you go to a hobby store, you know, like a craft store, like over here we have Pat Catan's. They're out of business now, but they've been taken over by Michaels or Joann Fabrics or, you know, Hobby Lobby, any number of hobby shops. You can buy what they call copper foil. It comes in rolls, and it's actually not super expensive for what the price of copper is these days. And one roll will last you years and years because it's, you know, the big long sheet rolled up. And you can cut it down with scissors and form it into the correct shape of the pad. And then you can fasten it down to the board. Sometimes I'll use some super glue or something to adhere it to the board. Sometimes I'll just tin it on both sides with solder and tin what's left of the trace that I want to attach to and just flow it all together, and that works really well. Another method I've used is you can actually buy copper tape. It's just real narrow roll of tape, and it's got adhesive on the back of it, and the front part is just real thin copper foil. And that's nice because you can cut it and then it'll just adhere down to the board, and then pop your little hole through it, run your component through it, and glue it, or solder it down. Other times I'll just take a piece of solid bus wire, you know, like number 22 gauge or something like that, you know, 0.5 millimeter, 1 millimeter wire, and I'll just run it along the trace. I'll clear off all of the solder mask and down to bare copper, and just put that in parallel to it, you know, right on top of it, and just flow solder on it. So those are 3 different methods that I use to repair boards, and I've had really good success with it. So it works. If you get good at it, it'll start to look really professional and neat. And even with those small repairs you make, sometimes you can't even tell you fixed it. You know, it just kind of looks like a little bit of extra solder on the pad than normal. And then you can get crazy, you know, put conformal coating over it, or get the green solder mask paint and kind of, you know, paint over it. Lots of different things you can do to make it look almost like you never worked on it. Hope that helps. Okay, shout out to my buddy Jeremy. This is from him. And check out his site if you get a chance sometime. He just started up. He has a YouTube channel called Possible Audio, and lots of fun. So he's been taking a little hiatus from the work for a little bit, but I'm sure he'll be back at it sooner or later. But anyway, Jeremy asks, give me your top 2 favorite integrated amplifiers. Oh boy. Your top 2 favorite receivers and your favorite tube amplifier. Wow. That's a real question there. That's a loaded question. You know, asking that kind of question is kind of like asking me, name your 2 best friends. You know, when you have 100 friends, and which one's your favorite? You know, it's hard to say that, you know. But let's just be a little bit, let's just use a little bit of theory on this. Integrated amplifiers. Well, first of all, let's just go by only integrated amplifiers that I've owned or have used, you know, where I could actually have an opinion. Because there's some that are out there that I think would probably be amazing, but I've never had one. So I kind of liked, for an integrated amplifier, I like the Pioneer, the SA9800. I like the sound of it. It has a very clean and fast sound, but it is a little bit fatiguing on my ears sometimes. That's just me. When it comes to clarity, though, and when it comes to low distortion, wow, that's one of those zero switching circuit design amps that they came out with on a few of their models. Great amplifier. I had that on my main system for quite a while. The second one would be the one that's on, you know, sitting on my system right now, and that's the Rotel. And what is it? The RA, let me look it up here. RA 1412. I love that that amplifier. It's beautiful. It's a work of art to look at it. It's built like a tank. It has dual power supplies, you know, dual mono power supplies. It has a pretty nice phono stage. It has 3 different levels of attenuation for the volume. So that volume control in a quiet room versus a loud room, it kind of changes the range of the volume. I love that. It has a loudness switch, which at low volumes, I kind of like using a loudness switch sometimes. Some amps don't have that. It's got adequate power. It's 100 watts per channel, but it's a very powerful 100 watts per channel, more than I would need for for my living room. So it's a good amp, and it has a really nice smooth sound. Not too bright, not too warm, kind of in between. Although I do love the sound of some of the Sansui gear and the Marantz for its warmness. That the 1180 DC that I just did the restoration on, I think if I had that up in the living room, I probably would get really attached to it because that is a warmer sounding amp, and it's very easy on the ears, although it doesn't have the brightness and so forth and the character of the other 2 that I just mentioned. It just has a nostalgic sound to it that I love. So that would be another one. My favorite 2 receivers. Well, it would have to be probably the Sansui 9090, not the DB, but the 9090, the one that has the quasi-complementary output. Of all the receivers that I've had on my bench and got to listen to, my cousin has a 9090 DB, and it's pretty much as good. But oh my, that's a great receiver. One of my favorites. And of course, it would have to be like a Pioneer SX 1050, 1080, 1980, something from that 5080 series Pioneer. And one more, I know you asked for 2, integrated amp. It's a dual sound good amp. It's only 65 watts per channel, but also I have to say the Pioneer SA 9100. I did one of the early restoration videos I did, or repair videos I did for one of the few people I did for, you know, my buddy Thomas. Thomas, Merry Christmas and Happy New Year. The old married couple. If you go back and look that up, wow, is that another amazing integrated amp. Last but not least, my favorite tube amplifier. I like the Fisher X101C. That's an integrated amp, but I really like that one. That's probably one of my favorites. I like the ICO ST70. A properly done one of those sounds beautiful. You're seeing a little pattern here. Most of them have the 7591 output tubes. Those are just in a class by themselves, especially if you can get your hands on the old ones, the originals. I mean, there are some remakes of them now, and they're pretty good. But you get an old Fisher, you know, like a 500 or X101, or like I said, that ICO, with those 7591s, they're just in a class by themselves. I've never personally heard a Macintosh like a 225 or, you know, Macintosh M. I don't know if they made a mono version, but the 25 watt Macintosh amp, tube amp with the 7591s, I think it's the 225. I bet that one's a really good one too. just my personal opinion from, you know, what I've heard. But yeah, that X101C, wow, that thing, and I have one, it's immaculate. You saw the video I did on it, I still have it, and I love that amp. All right, here's another good one. It's kind of a personal question. Not personal, but you know what I mean. With the rapid advancement and emerging trends in the electronics industry, how do you stay up to date? Are there any areas that particularly interest you, such as IoT, programming, microcontrollers, or digital electronics that you haven't explored much yet? Or do you primarily focus on analog electronics and vintage audio equipment, measurement instruments, and due to your line of work, of course, X-ray machines? And this is from Thailand. So, hi, Thailand. So, well, okay, let's go back to the beginning. My mother was a computer programmer. She was trained, she went to IBM all while I was growing up as a little kid. Spent a lot of time traveling to schools for IBM to train. She didn't work for IBM, she worked for a hospital. And when they first went from the old, white and green ledger books, for bookkeeping, and she was a bookkeeper, they offered her, of all people, the position of being the data processing director. And they were going to buy a new computer and get into the computer age. And she started out with an IBM System 3. You can look it up. Went through all this training and learned computers. And of course, I grew up at her knee. And she would take me in, and I would go into this giant room with all these massive cabinets and all these fans going on. I don't know. It just changed me as a person, And I remember my mom getting called at 2 in the morning to come into the hospitals. The computer would crash, and she'd have to go in and fix it and things like that. A monitor would go out, or all this stuff. And she would write software. I mean, some of the finance software she wrote, actually IBM used it in other hospitals and other installs for years after she even retired. But anyway, I got into computers for a while, and of course, being interested in that herself, one of the times my mom and dad splurged on me at Christmas time was they bought me a Commodore 64 with the tape drive, and then later on that next year I was able to get a 1541 disk drive to go with it. And I really got into that for a while. That was many, many years ago. And so I would like to get back into that a little bit. It has always fascinated me, computers and, like PCs like that, and digital, working with logic gates and things. I messed around with that, and then I just kind of, when I started getting into the X-ray business and I had to look at that stuff every day of my life at work, I just kind of lost interest in it. And software-based things and everything, I went back to my roots from when I was a kid. And right now, I like what I do. What you see me do on these videos, that's what I like now for fun. But I still do work with some of that other stuff. I have to for my line of work. So hope that kind of answers it. So if anything, yeah, I would like to get back into digital electronics a little bit, but I'm more interested in the analog, what I'm doing now, and history. I'm a big history buff, and I like, every time I work on old electronics back from the 20s, 30s, 40s, 50s, 60s, I'm just fascinated how brilliant these people were, that they thought up all this stuff. And that's what brought us to where we are today, with what we have today. It's all evolved from that. So there's 40 years of history there that I could never know all of it. So I'm still learning, and I'm still interested in it. And I think that's kind of where I am at this point in my life. Okay, Patrick, I gotta What about the Yamaha B6? Will you ever come back to this repair? I would really like to see you repair this amp and be proud of it. I believe you can do it. Really? Well, I will say that was one of the strangest and most interesting designs I've ever worked on. It is probably one of the most service unfriendly things I've ever worked on. I found out that, and you got anybody that knows these better than I do can correct me if I'm wrong, but there is a difference between the ones that were made for the Japanese market and the ones that were made for the United States market. The power supplies in them are different. So the schematics I have and had and so forth didn't necessarily jive with what I was working on. You're looking at an amp that was designed to work on 100 volts Japanese power, and I had to convert it to 120 volts American power. I don't know if they were using 50 or 60 hertz. I believe it was 60, so that was okay. But there were a lot of things when you use step up and step down transformers, you know, to change your mains voltage. A lot of those are either going to be auto transformers or something like that, or they're going to be toroidal transformers. When you're dealing with something that works with cutting up your sine wave, which is what those magnetic field type power supplies do with the triac and everything, you get a lot of strange things taking place when you're trying to power it with a step-down transformer or a step-up transformer. That was part of the problem with why we couldn't work on that. The other thing is you can't put one of those on a dim bulb tester because it fakes it out. It thinks that the voltage is real low. It tries to drive the frequency, you know, chopper frequency up on that triac. And then the bulb heats up real quick and limits the current, the voltage drops, the thing then goes nuts. So you can't, it's a moving target, so you can't use any type of current limiting circuit. And you can't have any kind of reactive component on your mains, or the amp will just self-destruct as soon as you turn it on. So that's not a really good design in my mind. You know, in my opinion, especially if you get one that wasn't made for the United States market. And I guess there were very few of them that were. There's more of them available that were made for the 100 volt Japanese power than for United States 120 volt mains. And that was part of the other problem with that. So no, I probably won't ever come back to that project. And I probably would not even take on a United States one because I don't like the design, and it's just too easy for things to go wrong after you do all this work, replace all these components, to just have the thing crash and burn on you again. So I hope that answers that. Okay, here's a good one. Happy New Year, Tony. I have a general question about amplifiers. What is the purpose or function of driver transistors and pre-driver transistors, and how do they impact the output transistors? Wow, that's an excellent question. A lot of us wonder that when we first get into this, and a lot of us just don't ask that question, or maybe even might be embarrassed to ask it because you should already know it. But no, there's more to it than that. Understand what an amplifier does. There's two different things an amplifier can amplify. It can amplify the voltage. It can amplify the current. And let's first look at the signal that you're trying to amplify. So you come out of your source, whether it's your mobile phone output or your tape deck or your turntable or your CD player or your digital music player. They have what's called a line level output, except for the phono. And it's a tiny signal. You know, it's usually less than 1 volt RMS of a signal. And that's really not, and it's high impedance, meaning that it can only maintain that voltage into a very high resistance load, because if you put too much of a load on it, it will drag that signal down because it can't deliver current. So you have a low voltage, low current signal, and you have to drive this speaker. A speaker has a low impedance voice coil, let's say 8 ohms, and you need a lot of energy to go into that speaker to move the voice coil, to push that cone in and out, to move the air and set up the sound pressure waves for your ear to hear. That requires a lot more voltage and a lot more current. So the purpose of the amplifier is to provide that voltage and current from that tiny signal. So you can't do it all at once. It would be nice if you could, but on a high-powered amplifier, when we start getting into 10, 20, 30, 50, 100, 500 watts, whatever you want, the first stage of an amplifier, the first part of your amplifier is going to amplify the voltage. So you want the amplitude of that signal to go up. So that's the whole purpose of your VAS, or your voltage amplification stage. And that's where you're going to see your pre-drivers and your drivers. They're going to take that small amplitude signal and increase it in amplitude to a larger amplitude signal. Now that's a great thing, because now you got the voltage you need to drive the speakers, but the problem is those little transistors can't dissipate enough current to provide the current that you need at those voltages to your speaker. So now you have to have something that can take that voltage level and provide the amount of current that you need to that low impedance load. So that's what the job of the outputs is. If you really measure the amplitude of, if you're looking on a scope at voltage, the drivers are going to have the same looking signal as the output transistors, because the outputs really don't amplify much as far as voltage goes. So theoretically, you could just connect a speaker directly to those drivers and it should work. But the problem is those little drivers can't handle that kind of current, so they overheat. When you draw excessive current through those transistors, they convert a lot of the energy into heat, and that heat will damage the transistor. So now you need a big beefy transistor that may not need to amplify the voltage anymore, but it needs to be able to handle that type of current flow through it. And that's the job of the outputs. So we amplify the voltage at first, and then the outputs handle the current end of it. And that's the purpose of drivers and pre-drivers. And you want to amplify your signal in stages. So that's why, like, the input pair kind of strips away all of the things that can be affected by that input signal, by your line level signal. And it converts it just a truly voltage controlled signal. And then your first VAS is going to be it's just going to be a single-ended, usually, transistor, and that's going to be your first amplification. And then you're going to go into another stage, that's your second stage of voltage amplification, to bring it up even further. And then you're going to usually go out into your outputs. So that's what that's all about. Okay, last one I'm going to do on this video. Hi Tony, what are your thoughts on the Master Groove Mend It Mark copyright strike regarding freedom of repair on YouTube? Well, freedom of repair is a different subject than freedom of YouTube, I believe. I am extremely adamant about right to repair. My company is a third-party company, a multi-vendor service company. We make our living working on equipment that we don't build. So I work on stuff from General Electric, Siemens, Philips, Toshiba, Hitachi, and so forth, plus my own brand of equipment that we sell. And I do not believe it's fair or even right for a manufacturer to build a very expensive piece of equipment and then put some silly encryption string on there. So for instance, you can't do a basic calibration of this machine that is being used to save lives. It's producing ionizing radiation in a very controlled manner. If you are unable to calibrate that unit so that it can maintain those very accurate levels, then you got a problem. And when a manufacturer refuses to let you get into, in the old days you had a pot that you tweaked, you know, you put your test equipment in there, you measured the output, you set the pot until it was adjusted. Everything's software driven now, and all they do is they put a lock on the software, they encrypt it so that they hide that menu so you can't get to it legally anyway, you know, without hacking the software to be able to work on it. And there's been arguments with it forever about, you know, well, we allow you, you know, you're not qualified to work on it. You know, that's not your job as the manufacturer to determine who's qualified or not. You know, we have the CRES program here in the United States. We have a lot of regulations that we have to meet. Just my business alone, every year, each state I have to have a license in, and so forth. So they have no authority to determine who can and can't service a piece of equipment. That's a government thing and a regulatory thing. The FDA handles that. The 21 CFR regulations regulate that. So I just think it's a bunch of baloney that these manufacturers create this equipment and for their own gain, because, you know, a third-party company might charge $200 an hour for service, and these guys are charging $600 to $800 an hour to do the same thing. And it's highway robbery. It increases the cost of healthcare. You know, a lot of people like to get down on the insurance companies and the medical facilities themselves, but when they're forced to pay prices like that, what choice do you have other than to pass it through to someone else? So it's a constant fight, is what I'm saying. And it's just something that in the 36 years I've been doing this now, I mean, my x-ray career has been 36 years now, and it's always been that way, cat and mouse. The government will step in and deregulate them, and then they'll come up with another way to block people, and then it just, the pendulum swings back and forth. So I am very right to repair oriented person, okay, from that end. Now, when it comes to YouTube, YouTube is a privately held company. I mean, well, technically not. It's, you know, it's part of Google and everything, but they are not a government organization. They are a private business that might be publicly held, you know, from shareholders, but they make their own rules. You know, when you agree to put content on their website, you have to agree to their terms and conditions. Most people never read that, but when you click yes, you're agreeing that they have control, you know. I don't pay anything to put my videos on YouTube. You know, I upload them and YouTube hosts them, and they make money off of me because they put advertisements or whatever, you know, and they'll share a little bit of that with us if we want to do it. But bottom line, it's a free service for the most part. And they make the rules, and, you know, they could delete my channel anytime, you know. That's why I don't put all my eggs in that basket. This is not a business to me, and I don't do it for money. And the little bit of money I do earn from this, I put back into the channel, and it helps me to make more videos and to afford to buy the parts and things you see that I use. But other than that, it's not a business. Other people, it is their business, and you just need to think about that if you're going to get into this for a living. I think that person who did the copyright strike, that company, they're being just like these x-ray companies, you know. If you are proud of the product you make, then you should have no problems people seeing what's inside of it. And if you're going to charge that kind of money for a product, and then you're going to be embarrassed when people show what's inside your product, to the point you're going to try to silence people over it, maybe you should rethink the way you make things, you know? I don't know. That definitely was not a copyright strike, if you ask me. The fact that YouTube just basically, you're guilty before proven innocent, and in the United States, you know, you are constitutionally innocent until proven guilty, unless it's involving the IRS. But you know, it's just it's a common belief that we have here in this country, and you know, for YouTube to just shut people down like that without researching it, I don't think that's a good thing. But again, their rules, their software, their channel, their whatever, you know, YouTube's their own business. But yeah, that dude probably shouldn't have done what he did. I think that was wrong, you know. You're better off, if you make a mistake in life, to own it. You know, I believe all of you that are watching right now are generally good, kind, forgiving people, as long as others are honest with you. You know, I will do things that are wrong on this channel. You've seen how many mistakes I've made. But when I find out that I'm wrong, the first thing I'm going to do is admit it. The second thing I'm going to do is apologize for it. The third thing I'm going to do is, if I can fix it, I will. You know, if I can't, then I just won't do that again. You know, but if I can fix it, you know, I'm going to come back and say, okay, this was wrong. Here's what it should be. And oh, by the way, here's the credit I'm giving to the person that showed me the right way, you know, in a comment or something. That's the way to handle life. That's the way to handle things like this. So there's my rant on that. I'm not one of these activist type people that will, you know, go up in arms over it, but it doesn't mean I don't have an opinion, and that's my opinion since you asked. So I wish Mendit Mark the best. I love his videos, and I hope he keeps making them, and I hope that doesn't discourage him in any way from doing what he does, because his videos and his procedure of doing things, his methods, absolute genius. So good for him. Well, I've only scratched the surface of the questions, but this will be part one. Hopefully, there might be one more like this of me sitting at my desk. If I get things squared away, we're very, very busy at work. I just finished an install of a brand new system. I'll flash a picture of it if you want to see. It's just a basic low-end system, you know, good, reliable, you know, nothing fancy, no robotics, none of that, no tracking, nothing like that, like some of the high-end ones. But this was the kind that I like to install because they're the easy ones. But we've been very busy. We got to do applications training. We have a whole bunch of inspections due, end of the year, beginning of the year stuff. So I have limited time. But when they finish the construction next week, and I can get down there and get things back put together how they should be, maybe I'll go back to the bench. So until then, you know what I'm going to say. I wish you all peace, joy, happiness, and good health in your lives. And I will see you again real soon. Probably here. And then the next video after that, we'll be back on the bench. Take care, everybody. Bye-bye.